Alright, so Hall effect keyboards have a lot of sick features, right? They've got stuff like adjustable actuation, stuff like rapid trigger, or they've got controller input, and it makes gaming feel nice and immersive and really responsive too. But if I'm being honest, a lot of that stuff kind of sounds like trash. They're either super muddy and thuddy, or they sound really rattly without nice satisfying top and bottom outs, and it's just not what I like about a good mechanical keyboard build. And a lot of other people agree. They try them and they say, yeah, this is really cool tech, but the people in the keyboard scene will be like, why does it sound like this? This is not the sound that I'm looking for in a keyboard. Now, there are three big reasons for this. The first thing is that the keyboards themselves kind of suck, as well as the companies that make them, because the companies that tend to make these keyboards are these gamer companies and budget Chinese companies. And there are some keyboard companies that do them, but in general, they tend to sound muddy and thuddy because the companies that do them oftentimes just use poor mounting styles and bad case design, and then they fill it up with foam to try to cover up the bad oral design, and that just kind of makes it sound pretty poor overall. The second thing is the switches themselves, because Hall effect switches right now just aren't as refined as a lot of those top tier mechanical switches. They also functionally work differently as well. So the molds that we see in a lot of these Hall effect switches tend to be not accounting for the differences between MX and Hall effect. And on top of that, they also seem to want to use really bad materials. I see most of the switches on the market being polycarbonate top housings or full polycarbonate housings, and it just doesn't sound that great compared to nylon, and we see that with MX switches. The other thing is that they have functional differences too. So not only do these differences make up for different sounds in and of themselves, but companies also don't seem to be really trying to work around them that much to account for those differences. So some of those differences would be like, in a Hall effect switch, there's no leaf. So they kind of rattle on the way down, and people don't like that sound. And there are companies that are trying to fix that by making them tighter, but I think that a big reason why they're doing that is also because making a Hall effect switch tighter improves the performance. But I think more importantly, we got to focus on sound, and that's why I'm not a big fan of self-aligning switches like the Gator Sparks, for example, or the Unionwells. The other thing is that the bottom has, we used to have open bottom switches, and now we've swapped to closed bottom switches for the most part, but that still has metal on plastic contact in a majority of switches, which doesn't sound great. Also, the springs are larger around the stem. The stem is larger to fit a magnet in it, and then you add springs around it that are larger, and that changes the sound as well. And there's a lot more differences. I could go on and on and on, but there's just so many different reasons for why they sound different, and we need a lot of innovation in the Hall effect scene to get them even close to what MX switches sound like. And then the last thing is that Hall effect keyboards have standoffs, and that's what this video is really about. Now, when it comes to that first issue, which is the keyboards itself, we can kind of put Hall effect PCBs in good cases to work around pre-built issues. Putting a Hall effect PCB in a premium case is actually one of the best ways to get a really nice premium Hall effect keyboard. The second issue is the switch design, and we can't really do much at home. Unless you're willing to design your own switch and like fully make a new one from scratch, you're going to be stuck at home, like kind of just swapping between different switches, trying everything out, and just kind of coping with the fact that all of them kind of suck. But the last one, which is the standoffs, we actually can do something about. But what do I mean by standoffs? So if you look at a Hall effect PCB, you'll see these little standoffs that are kind of scattered all over the board. And they look like little posts, and what they do is they connect the plate and the PCB together. They're not all in neat symmetrical places though. They're kind of sparsely placed around the PCB, and they're wherever the plate and PCB need some support to stay together. Now, on a normal mechanical keyboard, you've got 3-pin or 5-pin switches that hold the plate and the PCB together with metal contacts, which are sometimes even soldered. And a soldered MX PCB doesn't need standoffs to hold itself together, because the solder is really strong and it keeps them in place. But even with hot swap, the metal contacts make a big difference. You can see this at home. If you've got a hot swap PCB and a spare switch that you're fine sacrificing, you can take those two switches, cut the metal prongs off of one, and just kind of insert it in and out of a PCB. And you'll notice that it is much easier without the metal prongs compared to a switch with the metal prongs. And that difference multiplied by every switch across the board makes up for enough of a connection that the hot swap won't fall apart very easily. So in general, the MX structure doesn't rely as heavily on these random standoffs all over the place. We have seen it in some boards in the past, but it's very uncommon, and it's especially rare in a lot of the premium MX keyboard builds. But with Hall Effect, you don't have a traditional switch connection to the PCB. See, the way that the plate and the PCB interact without standoffs is with only two little plastic prongs that barely poke through the PCB, so manufacturers have to rely on these standoffs to keep everything rigid and lined up. Now those standoffs mechanically tie the PCB and plate together, and they keep it all connected so that stuff doesn't fall apart in use. But them being tied together is also part of the source of bad sound. Alright, so let's actually talk about how sound moves through a keyboard. See, the switch is your sound source, and that's where the initial vibration starts. You have the stem that hits the top and the bottom housings, and then you have a spring inside of that, and in the case of MX switches, there's some contact that's against a leaf. Now, having a good switch to start with is the source of all the sound. But there's a lot of factors outside of that that also contribute to the sound. See, from there, you have vibrations that travel into the plate and the PCB. And depending on the mount, either the plate or the PCB, or sometimes, like some rare cases, you'll have both, will then transfer that energy into the case. See, on a good MX board, the plate and PCB can sing on their own a little bit. The plate has its own resonance, and the PCB has its own resonance, and they're only tied together by the switches, which is the source of the sound. And that creates a nice harmony where together they reflect and shape the sound into something that's really nice, clear, open, and crisp. And that's why you get some really nice classics like MX Blacks on an aluminum plate, and they're really, really popular sound profiles because it's a really plate-forward Korean style sound that a lot of people love. On Hall Effect boards, though, the standoffs rigidly tie the plate and the PCB together. See, this is already done on MX with the connection between the plate and the PCB through the switches, but it's kind of taken to another level with the standoffs in Hall Effect boards. Because instead of the plate and the PCB resonating separately, they're locked into like one clunky, over-constrained system. And that changes the resonances and adds damping. And it also kills a bit of the ring and clarity, so you end up with something a bit more thuddy and compressed and muddy sounding, instead of something as open and crisp as it would usually be. Additionally, because they're placed sparsely around the board, they have different effects on each key individually. So you gotta imagine that instead of the plate and the PCB being tied together in the same way at every single switch, you have these standoffs throughout the board, and they affect the sound a lot more for any switches that are really close to them compared to switches that are further apart from all of those standoffs. Now, on a slightly separate note, there's this new mounting system that came out called Keysnap, and it functions really similar to a PCB gasket mount, but it has a little bit of a reminiscent sound of an O-ring mount. And it's meant for MX and Hall Effect. It works with both. And I've been using it on my main board instead of O-ring mount. So the reason why is that with a typical O-ring mount, you stretch the O-ring around the build, and then it sits between the case and the plate/PCB assembly, and you get this soft, bouncy, very O-ring type sound. I can't really describe it with any other words. It sounds like an O-ring mount. But the problem is, the O-ring can make things sound a bit choked because you've got this ring that's stretched around out to the edges and is under a lot of tension. So it pushes on keys and affects the sound of keys like the space bar, the backspace, and the other corner keys. And it's also not compatible with traditional MX hot swap PCBs because it pushes too much on the sides of the module, and it can cause de-seating because there's just too much force. And with normal MX hot swap PCBs that don't have standoffs or solder to hold it together, the switches can de-seat quite easily. So Keysnap is a mounting style that fixes the issues with O-ring while maintaining a similar but like slightly different sound. Now what I like about Keysnap is that the compatibility is insane. It's not just for O-ring mounted boards. It works with most cases, as long as they aren't tray mount or have weird wiggle room for their PCB. then it'll work. See, cases that are either fit too tightly against the PCB or just leave far too much room for the Keysnap to properly be seated won't work. But outside of that, the compatibility is crazy good. The other thing is that it's a little bit similar to O-ring in terms of sound, but the feel is stiffer. And a lot of people, including me, see that as a bit of a downside, but for me, even before I did this mod, the stiffer feel was completely worth it because the sound is a lot better. And the most important thing is that it mounts on the PCB itself. And that last part is especially huge because it changes how the plate and the PCB move when you press a key. And that's what lets us do this standoff removal mod for HE boards much more safely. See, with a normal mount, you press a key and the plate is what's really fixed to the case. And then the PCB it's along for the ride and can flex separately. So if you remove the standoffs, you get that separation between plate and PCB that I mentioned before, and you get the risk of de-seating some of the keys, and that'll run you into some performance issues on Hall effect boards. Now, with any kind of PCB mount, the mechanics change. For example, with Keysnap, which is PCB mounted and has great compatibility, the mount is on the PCB now. So when you press a key, the plate gets pushed down into the PCB as you're pushing on it, rather than separating from it because the PCB sits alone and in the air. So instead of having a pulling apart or separation kind of motion, you instead get a compression motion. The plate and the PCB are getting pushed together. So you don't need the standoffs anymore to keep the plate and the PCB from moving differently and getting further apart. And the Keysnap handles the mounting and the alignment by clamping that sandwich together in compression. So we can get away with removing the standoffs entirely with this setup. So here's the basic idea of the mod. What you're going to do is you're going to take apart your belt, and then you're just going to grip the standoffs with some pliers or something that can grip them tight and precisely, and you're going to do a slight twisting motion just to get them a little bit loose from the solder, and then you can ply them off when they're loose. And if you have a soldering iron, it can be even easier. Just simply heat up the backside, and then when the solder gets a little bit softer, you can just peel them off and rip them off really easily. You have to be careful though to not scratch the PCB. If you scratch the wrong spots and leave too deep of a gash, your board will be rendered completely defective. Now the good thing is that these standoffs, they're on the side that doesn't have any of the internals on it, so even if you do scratch it a little bit, it'll still work, but you do want to be careful. And then, once you do finish that, now that the standoffs are gone, you can reassemble the board as you normally would and then Keysnap it in as you desire. And then the goal is that in that finished build, the plate and the PCB are much more free to resonate, and the only real mounting interface is the Keysnap on the PCB. A few things to note though, this is not a reversible mod, so you have to be sure that you're fine with this being a permanent change, and that means making Keysnap a permanent change. The thing with this is that you'd think you could just solder the standoffs back into the PCB, but if you set them back in place by even like a fraction of a millimeter off of their original positions, it'll mess with the tolerances and also likely mess with the sound greatly too.